solve another Leetcode problem. 2747, count 0 request servers. So for this problem, it is inside the sliding window problem, and it is the hardest medium problem. Yeah, because for Leetcode, if it is a medium problem, normally the reading would be less than 2000, but for this one, it is 24,000. Yeah, so it means it is the hardest sliding window problem, but they label it as a medium problem because this is a template problem. Yeah, because if you did some problem like that, normally you can do it. Yeah, but the coding is a little bit difficult. Yeah, so let's first try to understand the problem. So this n just means n servers. So yeah, we are just giving an integer n, and we are also giving logs I, and we need to understand this logs. This I, the first index inside the logs, yeah, it is the server ID. So for example, this is ID 1, and the time is 3. Yeah, this donates the server with ID received a request at time. So this means at time 3, this server with ID 1 will receive a request. We are also giving an integer x. So this x is just used for the queries. So for example, if the query is 10, yeah, it means for our interval, it will be queries I minus x. So it means 10 minus 5, it is 5. To this queries I to 10. It means the first query, the first interval will be 5 to 10. The second interval will be 11 minus 5. So it is 6 to 11. So this is a fixed window. Yeah, so the window size is 5. Yeah, we should know about it. And what we need to return? We need to return a 0-indexed integer array of less queries length. So the query length is 2. So our result is also 2. Yeah, where the queries I represents the number of servers that did not receive any requests. So for the first place, this means how many servers did not receive the request. So for our interval, the first query it is 10. So the interval is 5 to 10. So for 5 to 10, so server 2 and server 1 received the request, but server 3 does not, because there's no server 3. As you can see, there's no server 3. So that is why the result is n minus 2. It is 1. So for this 11, the interval is 6 to 11. Yeah, if it is 6 to 11, we can check that. Yeah, for this server with ID 2, it is 6. So it means this one received a request. Yeah, so what about server 1? So for this ID 1, the time is 3. Another one, the time is 5. So it means one didn't receive. Also, ID 3 didn't receive. So there are 2 servers didn't receive. That is why we get a result of 1 and 2. Yeah. Now let me make a drawing, because this problem is gonna be difficult to understand with just coding. Yeah. Why it is yeah. First of all, this problem is an offline query problem. Why it is offline query? Because the queries is given. So for each of the queries, it is given, and the maximum we're gonna have 10 to the power of 5 queries. Yeah. But this query is given. This means we can handle with this query. We can do some calculations with the query. Normally we're gonna sort the query. Yeah. Now let's try to understand. Yeah, let me use the first example. We have some logs like 1, 2, 3 with ID 1 times 3, and we have another log. The second log, it would be 226. Yeah, 226, and we have another log. It is 1, 5. This ID with 1 and times 5, it will receive request. Yeah, so this is our logs. Now we have a queries. So the query is offline query, but we are giving. Yeah, we are also giving an x. Currently this x is 5. Yeah, and the query inside it is 10 and 11. We want to calculate the result. So the length of the result array is also 2, because we have 2 queries. Yeah. So how can we solve this problem in n log n time? Yeah, because if we use n square, it is not possible, because n is 10 to the power of 5. Yeah. So this means we can do some sorting. If we can sort out the array, normally we can do it easily. Yeah. After sorting, we might use some algorithm to solve it, and this algorithm would be sliding window. Why we can sort it? So first of all, we are giving this logs array, and this is randomly given, but we can sort it according to the time. Yeah. Why? Because we are also giving a queries array. The queries array, each of the item is also the time, so this 10 means a time. Actually, this 10 just means 5 to 10, because 10 minus 5, it is 5. Yeah, it means an interval of 5 to 10, and both ends included. And another interval, it is 6 to 11. Yeah, both ends is included. So the size of the window, as you can see it is 5. It is fixed like X. Yeah. Now, if we can sort out this array according to the time, maybe we can also sort out the queries according to the time. Yeah. If we sort out the array in increasing order, it will be like 1, 3. Next one would be 1, 5. And the third one will be 2, 6. Yeah, this is just after the sorting, according to this time. Yeah, according to the second index. So this is what we sorted. But what if we can sort out the queries? So for example, if the queries is 11 and 10. Yeah, but we can sort it according to this time. But we need to find the index of each of the item, otherwise we cannot find it. Yeah, so we're gonna give an index for this query. So for example, we have a query like 11 and 10. So before it is 11, first of all, I'm gonna take this index first. So the index is 0 with 11. And the second one is index 1 with 10, because I'm gonna use this example. Yeah, I'm gonna use this example because this example is more easy to explain. Yeah, to explain the sorting. So before we have a query like that. Yeah, we're gonna use some index to record where we need to put into our result, because we're gonna prepare a result array. So for example, we're gonna prepare a result array. So the length of the result array is just the length of the query. Yeah, we just need to put something inside this result array. Now, if we can sort this one, yeah, the first place is gonna be 1. So if we sort out this one, after sorting, it will be 1 and 10. This one is just an index, and the 10 is time. Yeah, so the next one would be 0 with 11. Yeah, so after that, we can calculate like one by one. So first of all, for this one, we're gonna calculate, and then we're gonna calculate the second one. But for each of the queries, we can directly get the result, because this ID, this index, is the position where we need to put for the result. So for example, the result have index 0 and index 1. So for this one, we're gonna first put the index 1, put the result inside the index 1. So for example, this one maybe, yeah, I forget the testing result. Maybe this is 2, or maybe at index 0 it is 1, or maybe this is 1 and this is 2, but this is our result array. After that, we will return our result array. Yeah, but how can we use the sliding window? Yeah, because this array is sorted for the logs, and the query is also sorted. Yeah, so in this example, let's try one by one. So we are going to calculate the servers, which is out of the range. Yeah, so we are going to return. We are going to find the number of servers that did not receive any request. So I'm gonna use the out of range to represent it. So from the beginning, the out of range, I'm gonna define it, the out of range, as n. N is, for example, in this example, n is 3 because there are 3 servers. Yeah, I just imagine there are n servers out of a range from the beginning. Yeah, now I'm going to check it. So for the first query, it is like this ID with this index with 1, and it is 10. So I'm going to check it from 5 to 10. Yeah. Now I'm going to check this one. How can I check? I'm gonna use a left pointer and the right pointer to check. So first for the right pointer, it is 10. I'm gonna check one by one. If it is less than 10, I'm gonna put it inside a count array. Yeah, I also need to prepare a count array. So this count array with the index like 0, 1, and 2. So this 0, 1, and 2 just means I have 3 servers. Yeah. I'm gonna use n-1. Yeah, because I don't need to use this 0 index. I'm gonna use 1, 2, 3. This is gonna be easier to check. Yeah, basically it's the same idea. Or you can use a hash table, it's the same. But for this case, we can just use an array because array normally gonna be much faster than hash table. Yeah. Now we are going to check it. So for this 5 to 10, we're gonna check the first one. So this is ID 1 with 3. Is 3 in between 5 to 10? Yeah. I'm gonna use two ends to check. First of all, I'm gonna check this 10. Yeah, if some values which is less than and equal to 10, so for example, I'm gonna find some values which is less than 10. And for some values, I'm gonna find some values which gonna be less than 5. Yeah. For example, let me try this example. First of all, I'm going to check the right pointer. It should be less than and equal to 10. And then I'm going to check the left pointer. It's going to be less than 5. So inside, how can I count it? I'm going to use a counter to count how many values inside. Yeah. So for example, I'm going to check one by one. I'm going to first use the right pointer. This value is less than or equal to 10. So what is the ID? So the ID is 1. So I'm gonna count it as 1. So I have a count of 1. Yeah, but currently I'm gonna use an out of range variable to check how many servers is just out of range. From the beginning, the out of range is n. It is 3. Yeah, if I find 1, it is inside the range. It means the out of range should be -1. Yeah, because in total out of range is n. If some servers inside the range, it's gonna be -1. So for example, this one 3 is inside the range less than or equal to 10. So I'm gonna count it by 1, and then I'm gonna check this ID. Yeah, ID also with 1, and it is 5. So 5 is less than or equal to 10. So I'm gonna count it as 2. But even for this ID, I count it as 2. I will not minus this out of range servers, because for this ID 1, I've already counted, so I have to count it 1 time. I cannot count it 2 times because I'm going to count the different servers. Yeah, because for this 1 and 1, it's the same server. Yeah, but for my count array, I'm gonna count it. Yeah, so this is my count array, and then I'm gonna check the last one. It is ID 2 with 6. So ID 2, 6, I'm gonna count it as 1. And how many servers out of range? First of all, it -1, and then it will minus another one, because for this ID 2, it's a different ID, right? So currently, how many servers out of range? It is 1. Yeah, this is for checking the servers less than or equal to 10. So what about we check the servers less than 5? Yeah, so this is for the left pointer. Yeah, so for this one, it is 3. 3 is less than 5. Yeah, so before there are one server out of range, but currently we find another one, which is this is 3. It is less than 5. So we're gonna plus 1. Before it is 1, now it is 2 servers out of range. Yeah, because for this 3, definitely it is less than 5. Yeah, if it is less than 5, so we're gonna plus 1. So it means 2 servers out of range. Now we're gonna check this one, the second one. It is ID with 1 and 5. So 5 is not less than 5, right? Yeah. 5 is more than or equal to 5. Yeah, but we cannot not count it yet, because currently the count for this ID 1 is 2. Yeah, we're gonna first minus 1. Yeah, if we minus 1 with this ID 1, it is 1. So if it is 1, we're gonna not plus it. Yeah, because currently we still have some IDs. Because for this ID, it is still 1. So how many count? It is still 1. Yeah, because for the next one, the ID 2 with 6, 6 is more than 5. So we're gonna not minus this one. Yeah, because it is more than 5. We just count the left pointer less than 5. So how many servers out of a range? It is only one server out of a range. So it is this one. So this is exactly what we calculated, because we're gonna calculate 5 to 10, and this one is just 3. Yeah, this one is just 3. Yeah, actually for the servers it is the ID with ID 3. So yeah, but for that ID 3, we've already counted as already out of range. It is n, it is 3. Yeah, but we minus 1, or we find one servers out of range. But even we're gonna check some values less than 5, but it is still 1. Actually, this one just means the server with ID 3 just out of range. Yeah, let me just start coding. This problem is gonna be a little bit difficult to understand, but if you did some problem like that, this is actually a template problem. It is called offline query with the sliding window problem. Yeah. So I'm gonna prepare some variables. I'm gonna let me just first sort the logs first. Yeah. So I'm gonna sort the logs. So this will be nlog n time. Yeah, so k should be equal to lambda, and I'm gonna check this logs with index 1. Yeah, because I'm gonna sort the time in increasing order. Now I'm gonna prepare a left and right pointer, both starting from I'm gonna prepare the pointer later because I'm gonna use the sliding window later. Yeah, I'm gonna prepare a result array. So the result would be 0 times n plus 1. Yeah, because I'm not going to use the index 0 because the servers is just with ID 1 to n. So this is why I'm gonna use n plus 1. And I also need a count array. So this count array is just the length of the queries. So let me use the length of the so this count array is let me check this count array. So this count array is just starting from index 0 to 3. Yeah, so it should be 0 times n. Yeah, I believe it should be 0 to n minus 1 for the for the index. Yeah, but I will change it later if it is wrong. And I'm going to use out of range. So this means how many servers out of range. It's gonna be starting from 0, and then I'm gonna prepare a left pointer and a right pointer. Now I'm going to start the sliding window part. So I'm gonna use enumerate for the sorted queries. So for the index and query in a sorted enumerate. Yeah, I'm gonna sort it enumerate, because in this way I can record the ID and the query as well. So enumerate the queries with k equal to lambda, and I'm gonna check the queries actually. So it should be x1 because x0 is just the index. So in this way I have a record of the index with this I, and then my result array would get the yeah, my result array. So the count should be n plus 1. Yeah, because I'm gonna count using the index 1 to n. Yeah, but for this result array, it should be n times length of the queries, because the result is just the length of the queries. Yeah, now it should be okay. Yeah, because finally I'm gonna use this ID to get the result. This ID should be equal to this index should be equal to out of range, but this will be the final result. Finally, I'm gonna return this result, but how can I get it? Yeah, I'm gonna use the sliding window. First of all, I'm gonna check this right pointer. So for this right pointer, so the r should be less than the length of the logs, and yeah, we can use logs r with r starting with 0. Yeah, r with index 1. So if it is less than equal to equal to queries equal to q, so it means we're gonna use this while check to check how many servers will be less than equal to this q. So for example, this q is 10. How many time which is less than equal to 10, but we're gonna record the ID inside the count. Yeah. So if it is like that, we can use the out of range maybe. Yeah. So the out of range would be, yeah, if it is inside out of range would be -1. Yeah. Now after that, we can also check the left pointer. Yeah. So while this left pointer less than the length of logs, and the logs L with 1 less than, yeah, here we can use less than this q minus x, right? This is a q minus x. Yeah, so this one is less than equal, this is the length. Now it can calculate how many servers in between. If we want to calculate the out of range, should be starting from this n, because from the beginning we just imagined the out of range would be 3, and then we're gonna check. So if something is less than equal to this q, so the out of range would be -1. Yeah, because we believe something inside the range, we're gonna -1. Yeah, but after we find that, check out after we get the out of range, but if we also find some values which is less than q minus x, our out of range should be +1. Finally, we get the out of range. Yeah, but before the final result, we need to check 1 we need to minus this one, and 1 we need to plus this one. Yeah, this is actually we need to check. We need to check this count. We're gonna use this count array as a hash table to check. Yeah, first of all, we can get ID. So I'm gonna use the lowercase d. So the ID should be logs. Yeah, logs r with 0. So this is just the sliding window for the right pointer. We're gonna check if this is right pointer less than the length of the logs, and with index 1 it is less than the q. So first of all, we got an ID. Yeah, because the ID is just a logs r with 0. Yeah, and similarly here I just copy an ID. Yeah, first of all, let's analyze the right pointer. So for this ID, I'm gonna use a count with this ID. Yeah, so for this count ID, what should this count ID do? So this count ID should plus equal to 1. Yeah, but we need to check this count ID. It should be equal to 0. Yeah, then the out of range would be -1. But this one cannot plus 1 first, otherwise it can never be 0. Yeah, so this means we need to check this 0 first. First of all, we're gonna check this ID. If it is equal to 0 from the beginning, because it means there's no servers, but suddenly we're gonna use this ID plus 1. Yeah, because we're gonna add 1 server. Yeah, so if it is equal to 0, definitely we are sure the out of range for the servers would be -1, because the next step, this count of ID would +1. Yeah. So if this count of ID is 1, 2, it is more than 1, it can never be 0. So this out of range will not be -1. Yeah, because this out of range is just a counter for counting how many servers, and because this result with this index should be equal to this out of range. This just means how many different servers. Yeah, so this is why we're gonna use a check. So this check is very important for such kind of a sliding window problem. Yeah. Now our R pointer should be plus equal to 1, because this R pointer would be always shifted to the right. Yeah. After that, we can check the left pointer. Yeah, similarly, we're gonna have the same check. Yeah, finally, the L pointer should be plus equal to 1. This L pointer would always be go to the right direction, and this right pointer always go to the right direction, because this is the sliding window. Actually, this whole part, the time complexity is just in these areas. It is n log n. And for here, there's another sorting. So this is another m log m. So the total time complexity is n log n, m log m, and on. So this count, for this count, this n, we're gonna use on. So this is why it can pass. Yeah. Now let's check if there's something wrong, because I didn't check the left pointer yet. So first of all, I can get an ID, and then, yeah, I'm gonna check if this ID equal to 0. If it is equal to 0, so the out of range should be +1, because it is less than q minus x. Yeah. If now I can delete this line. Yeah, but I need to check this count ID. I didn't use this line yet. Yeah. So normally the count of ID should be some places. It can be after that, or it can be before it. Yeah, it can be before the if check. So the out of ID should be -1. Yeah. But where this line should be, it should be after if or before if. Yeah. So here we just need to check if this ID equal to 0. So if this ID equal to 0, just less than q minus x, this ID equal to 0, definitely out of range would be +1. Yeah. But what about the count ID? It should be -1 before or after this if check. Yeah. So here it should be just before. Yeah, because if you put it before, for example, before this ID is count ID, with this ID, the count ID, the result is 1. So 1 minus 1, it is 0. So this 0 means there's this server, there's no server. Yeah, because the code is 0, we can check it. Yeah. Otherwise, if we put this line just after this if, yeah, for example, before it is 1, and it can never be 0. Yeah. Now we're gonna check it. This will be +1, but it is not, because it didn't minus this one. Yeah. But for the next check, this ID, there will be another new ID. So definitely it's gonna be wrong. So this is why this ID will be here. Yeah. This count ID -1 will be here. Yeah. Now let's check if there's something wrong with the whole program. So here we first sort it and get result and get count and get out of range, L and R pointer, and this is the sliding window part. And for this I is just a record of the final result. Yeah. Now let me run it to check if there's any problem. This sort is wrong. Where is it? Yeah, because I should use a logs.sort. Yeah. Yeah, because here I'm gonna use the logs.sort. Yeah, it's not sorted. Here, this list out of range, because here I need to change it to the L pointer, because here I checked the L pointer. Yeah, it should be the L pointer. Now let me run it, As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it passed all the testing cases. And the time complexity is, for this sorting, it is m log m, and for this sorting, it is n log n, and for this count array, it is L. So it is L plus n log n plus m log m. So this is why it can pass for the Leetcode. Yeah, you may think this may be O(n) squared. Actually, it is not, because this is a sliding window. This is the R pointer. It is always go to the right. This is L pointer. This L pointer is always go to the right. Yeah, this is why it is so fast, because we're gonna use this, because this query has already been sorted and the logs has been sorted as well. This is why we can use a sliding window to get the result. Thank you for watching.